Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. In the previous lecture, we have been covering the topic econometrics and we have almost come to the end of it. This topic comes under Statistics Paper 3 Descriptive Type and is considered one of the most important topic and crucial as well because this topic isn't taught in our colleges, mostly isn't taught in our colleges, and this comes in the syllabus and which is related to economics basically. So this is one of the major topics that children don't know how to cover and from where to cover. So this is the online platform where we focus on ISS exam specifically, and our main goal is ISS 2026. As we have been covering this topic and coming to an end, I would like all of you to see all our lecture videos on this topic, and then we'll move to another topic and keep on practicing with us. If you have doubts, then you can ask us on WhatsApp channel or in the comment section. So, in today's topic, we will cover two topics. Firstly, is the prediction of simultaneous equation model, and second is the class confidence interval of simultaneous equation model. So, let us begin. Prediction of simultaneous equation model. Generally, we can write our general simultaneous equation model can be written as a y plus b x is equals to epsilon. This can be written our model as generally. So here we can take a y is equals to minus bx plus epsilon, and we can take inverse of a, multiplying with inverse of a on both sides. A y is equals to minus a inverse b x plus a inverse epsilon. This can be written as y is equals to pi x plus epsilon star, where pi is nothing but minus a inverse b and epsilon star is nothing but a inverse epsilon. So this is our general model, SEM model that we have taken. We have proved it in the previous lecture. You can see that how does this come. Then here we have put it in this kind of form, which is multiple linear regression model. This is a multiple linear regression model kind of form. Now we will find the prediction. So there are two cases of prediction. First one is case 1, when variance of epsilon is equals to sigma square I, which is constant. Then we will use simply OLS estimation method. Simply in this, we will use OLS estimation. We will first find out the estimation of pi, and we will put in y, and we will get the estimation of y cap. And second is when variance of epsilon is not equal to sigma square in, or let it be equal to sigma. So in this case, we will find by GLS, generalized least square estimation method. Firstly, we will predict sigma cap. Firstly, we will predict in this method, we will predict sigma cap. And the second thing is we will take epsilon as y minus pi x. So our by GLS we will first GLS where E is equals to epsilon dash epsilon, which is nothing but y minus pi x dash y minus pi x. This can be written as y dash y minus 2 x dash pi x dash pi y plus 2 x dash pi dash pi x. This will come. Now differentiating this with respect to pi, we will get 0 minus 2 x dash y plus 2 x pi dash, or let us say simply pi x. This will be it. Then the normal equation will be differentiation equation equal to 0. If we put this equals to 0, we will get x dash y is equals to x dash pi x. This will be. Now how can we solve this? We have obtained the equation x dash pi x is equals to x dash y. We have to find the estimation of pi. So firstly we will multiply by x dash inverse on both sides. And then we will multiply by x inverse on both sides. So we will get pi cap is equals to x dash inverse x dash y x inverse. This will be our estimation for pi, and hence the predicted value of y cap is nothing but pi cap x. Here comes the prediction of y cap. This term can also be written as y x inverse, because x dash inverse and x dash will cancel out and it will be y x inverse, or simply you can write it in this form. This is also correct. So we have till now covered prediction of simultaneous equation model. Firstly, we have written the general form of simultaneous equation model, solved it in multiple linear regression model, and then we have calculated the two cases. Case 1 is when variance is constant, and case 2 is when variance is not constant. So when variance is constant, we will simply apply OLS estimation method, and when variance is not constant, firstly we have to predict the variance also, which is sigma cap, and then we will apply GLS method, generalized linear least square estimation method, and by applying that we will get our prediction of the estimator, and then we can predict our y variable. Next one is, the next topic for today is confidence interval of simultaneous equations model. Let us consider the model y is equals to x beta plus epsilon. This is the given model to us. Now how do we predict the now variance? We know that estimation of epsilon is nothing but 0 vector, and variance of epsilon is equals to sigma square x dash x inverse. These are the two things that we know that. So now we will find the confidence interval. Confidence interval for beta can be written as beta cap plus minus under root of variance of beta cap. Now here beta is nothing but beta 1, beta 2 up till beta p. Suppose that this is it. Now if in this in the solving the confidence interval with this normal method, we will let us consider that the level of significance is 0.05. So 1 minus alpha percent will be 95%. This will be the now let us take p is equals to 10. So the probability of occurrence of error is nothing but 1 minus alpha raised to the power p, which is nothing but 0.95 raised to the power 10, which comes out to be almost equal to 60%. So this is a huge margin of error. We are getting a huge margin of error, which is probability. The probability of error is huge, very huge, which is 60%. And we cannot afford error. We are doing probability just to decrease error, or this whole econometrics model is based on reduction of error or diminishing of error from our model. But here we are getting 60% of error. So there is a method which is known as Bonferroni method. Bonferroni's method. Here we will calculate the value of eta, which is error term, which is nothing but alpha upon p. We will calculate this, and after calculating this, we will calculate the CI. CI will be beta dash plus minus p eta by 2 eta minus p into under root of variance of beta dash. This is reduction of error. This constant eta is known as reduction of error component, and this can be reduced to this can be used to reduce the error component. And firstly we will calculate this, and after that we will put this in t table, and we will get a less error based model and confidence interval. So in today's lecture, we have completed two important topics. One is precision, and the second one is confidence interval of simultaneous equation model. This completes your simultaneous equation model. Now we are left with Thiel-Bloss process and K-class estimator. I will try to complete both the topics in the tomorrow's class, and then we'll first discuss what all we have covered and whether we have covered all the topics or not, and then we'll start with another topic of similar paper 3. uh, you should keep on doing this work in your notebook. Keep on practicing doing pyqs, every pyqs. This precision and confidence interval has not been asked yet, but they can be asked in the upcoming examination, and you will write them as it is. They have given here I have explained you in the class. and you'll get all good marks in that. And if you're having any doubt, then you can ask us on WhatsApp channel or Telegram channel or in comment section. Relevant doubts will be answered. Many of you have been asking the questions, which is very appreciative, which tells us that you are taking it seriously. Thank you.